Good, good morning, one and all present here. Myself Latha. I'm from final year EEE department. Now I'm going to present my PPTs based on short line fault or kilometer fault in power system transient. First thing, what is short line or kilometer fault? Short circuit fault occurring on a transmission line between 0.5 to 5 kilometers are termed as short line fault or kilometer fault. A fault of this imposes a highly duty on a circuit breaker, thereby affecting its interrupting abilities. Then there are types of faults occur in it. There are two types of faults occur in it, which may be for high voltage transmission network. It is customary to identify the type of fault occurs in it. There are two types of fault, and they are terminal fault and short line fault. The terminal fault states that a terminal fault is defined as that where the short circuit takes place or at very near the terminal of the circuit, or near to the terminal of the circuit. And short line fault is nothing but is one where the short circuit is occurs at a relatively short distance from the circuit breaker or on its load sides. Mostly these types of faults are occur in between the range or in between the given range. It may be varies from 0.5 kilometer to 5 kilometers. If it is occur in the middle, it is then short line fault due to the short circuit. If it is at the end of the nearer to the point which going to be terminates, is called terminal fault. The short line fault is also known as to be kilometer fault, since there is generally considered to be the critical distance for maximum severity of the recovery voltage. A short line fault, the circuit breaker is more likely to fail in the thermal recovery regions. The short circuit basic phenomenon. This is the diagram which shows the short circuit fault. Here a voltage supply is given in the line is a transmission line which is placed after the breakers. When the fault occurs in between, it is then due to the short circuit. It is in short circuit fault. It is if the fault is occur nearer to the point which is said to be the 2 points in between a short range, or A or B, the point is said to be the terminal fault. It is a network diagram which is shown here. Then on a supply side, if a circuit breaker, the voltage will oscillate at supply frequencies, ultimately approaching the open voltage. On the line side, the circuit breaker is tapped, charges after interruptions, initiates waves on the transmission line, and this waves imposes a sawtooth waveforms in the circuit interruptions. Since there is no driving voltage on the driving sides, the voltage ultimately becomes zero because of the line losses. Even though the magnitude of the voltage oscillations is considerably lower than the system's voltage, the frequency is very high, because this means that the rate of rise of recovery voltage, which is said to be triple RV across the circuit breaker, can be much higher than the terminal short circuit cases. In there may be the three types. It is a rate of rise of recovery voltage, and it is also another one is high rate of rise of recovery voltage, and the third one is very high triple RV. The second thing, high RRV, may be causes interrupted to fail. It is also causes near to the short circuit current is quite less. Thus the extra high voltage circuit breakers which is sensitive to triple RV, there may be critical line length. Very high triple RV is of up to 10 kilovolt per microsecond have been encountered during the short line fault. Shorter line length gives the higher rate in rise of recovery voltage, but the voltage peaks becomes so low, the circuit breakers clear easily. Then in the oscillogram of line ground voltage diagrams is shown here. It is a diagram which shows the line ground phase voltage which is measured. Is this shows a line to ground fault can be produced and over voltage on an unfaulted phases is 2.1 times normal line to neutral voltage on three phase lines. From the oscillogram, it is observed that the maximum over voltage occur at the midpoint of the line. The line to ground voltage is obtained in TNV. TNA stands for transient network analysis at midpoint of the three-phase line for two single line to ground fault at that point. The over voltage decreases slowly as the fault location changes, but the maximum remains 1.7 pu for locations over about 67% of transmission lines. This is the things which is used as the which is shows that a short line fault or kilometers fault. Thank you all.